Wow, I actually did it. I'm in math. This is awesome. It's okay, nothing can hurt me here. Wait a second. Hi everybody, I'm Mr. Wheeler and welcome to another episode of Lost in Math. Today we're learning about transformations of quadratic functions. For everything we talk about today, we have to assume that our quadratic function is written in standard form, y equals ax squared plus bx plus c. So all of our equations are written in standard form for the video today. We already learned earlier, card in the top right-hand corner, that a, when it's written in standard form, controls whether my parabola opens up or down. So if a is a positive number, it opens up, and if a is a negative number, it opens down. So that's one transformation I can do. I can flip my parabola up or down by changing the sign of a. A also controls the width of a parabola. The larger the absolute value of a becomes, the narrower our parabola becomes. And the smaller the absolute value of a becomes, the wider our parabola becomes. We have to talk about the absolute value of a because changing between positive and negative doesn't affect the width of a parabola. It just affects which way it opens. So the graph of y equals 2x squared would be the same width as the graph of y equals negative 2x squared. Just one would face up and one would face down, but they'd both be equally as wide. So that's why we have to talk about the absolute value of a. So bigger a gets, narrower the graph becomes, smaller a gets, wider the graph becomes. So if we look at our example here, f of x equals x squared. So that parabola is f of x. F of x equals x squared, so my a is equal to 1. That's the number multiplying my x squared. H of x is equal to 1/4 x squared. It's that parabola there. 1/4 x squared, the absolute value of 1/4 is less than the absolute value of 1. So that's why h of x is wider than f of x, because my a got smaller. G of x equals negative 3x squared. The absolute value of negative 3 is positive 3, and 3 is larger than 1. So that's why the graph of g of x is narrower than f of x and h of x. It's facing down because I got a negative 3, so since it's negative, it opens down, but it's narrower because 3 is larger than 1. So A controls which way the graph faces, up or down, and it also controls the width. The larger the absolute value of A, the narrower it becomes. The smaller the absolute value of A, the wider it becomes. So if we looked at this example here, could you tell which equation for g of x could describe the graph? The answer is B. G of x is wider than f of x. F of x had an a value of 1, so g of x needs to have an a value whose absolute value is less than 1. So it can either be B or D, because 1/2 is smaller than 1. It's B because my graph opens up, so I want my a to be positive. So that's the only choice that it could be. Could you do this example? The answer is C. G of x is narrower than f of x, so I know my answer is either going to be A or C, because 2 is larger than 1, and the bigger a gets, the narrower my graph becomes. And then it's C because my graph opens down, so I want my a to be negative, so negative 2x squared is the only choice it could be. The last transformation we're going to talk about is the vertical positioning of a parabola. C, when it's written in standard form, controls where it is, vertically speaking. C, we remember, was our y-intercept. So if I increase C, my parabola will shift up. And if I decrease C, it'll shift down. So if we look at our examples here on our paper, g of x is this parabola here because it shifted it up 4. It was f of x equals x squared. G of x is x squared plus 4, so it would have moved up 4 units. H of x is this graph here. My c value changed to -3, -3, so it went down 3 units. Smaller c gets, it goes down. Bigger c gets, it goes up. If we looked at this example here, could you figure out which was the equation for g of x? It would be b. First of all, my graph is wider, so I need my a to get smaller than 1. So my choices are between b and d. My y-intercept, my parabola, shifted down. So that's why it would be a -3 for my c value, because my parabola moved down. So b is the only choice it could be. Could you do this example? The answer is A. My parabola is narrower and facing down, so my choices are between A and C, because those both have a -2 as my A value. Negative, so it's facing down, and 2 is larger than 1, so it's narrower. But it's A because my y-intercept moved up, my parabola moved up 3 units, so that's why it's +3, because it shifted upwards. On the back of our notes, we have a couple of practice problems. It asks us to arrange these functions from widest to narrowest. So take a moment and try and do that. Number 1 was already written in the right order. F of x, g of x, h of x. The absolute value of a on f of x was 1/2. That was the smallest one, so it's my widest graph. On g of x, the absolute value of a was 2, next smallest, so it's the next widest. And then on h, the absolute value of a was 5, the largest one, so my narrowest graph. So f of x, g of x, h of x. Example 2 is g of x, f of x, h of x. G of x is my widest because the absolute value of a is 1/4, my smallest number. Next is f of x. Absolute value of a is 1/3, my next smallest number. And last is h of x. Absolute value of a is 4/5, my largest fraction. So that's the order: g of x, f of x, h of x. Our next two practice problems asked us to compare the functions given with the function f of x equals x squared. So think about how each graph would look and compare them. On example 1, g of x is -1/2 x squared minus 2x plus 3. My a is -1/2. It's negative, so it's facing down, and it's 1/2, which is smaller than 1, so it'll be wider. And my c value is +3, so I know my y-intercept will be shifted up 3 units, since my y-intercept on f of x was at 0. So it asked me to compare the two, so I could write something like g of x is wider, it's facing down, and its y-intercept is shifted up 3 units. That'd be a nice answer. On number 2, g of x equals 3x squared plus 2x minus 5. 3 is bigger than 1, so my graph is going to be narrower. And minus 5, my y-intercept went down 5. So for my answer, I could write something like g of x is narrower, and the y-intercept is shifted down 5 units. I'm comparing the two, so I don't need to say it's facing up, because f of x was already facing up. If you want to say it's facing up, that's fine, but either way. So that wraps up our notes on transformations of quadratic functions. Like the video if you enjoyed it. Don't forget to subscribe so you're not missing a thing. And see y'all next time. Bye, guys. talking about width and narrowness. I don't. This is weird to talk about without pictures. Absolute value, remember, is how far a number is from 0 on the number line. So absolute values are always positive numbers. A also controls. So if we look at our example here, to do this, we look at our C value, and when it's written, my C value, my parabola will move down on the y-axis. It doesn't really move, it just is. H of x is equal to 1/4 x squared. So h of x is equal to 1/4 x squared. Sorry, I'm starting. A, whose absolute value is less than 1. Okay, stop. So it's either going to be this one or not this one. Can I? The answer is A. 1/2 x squared plus negative 1/2 x squared minus 2x plus 3. So that wraps up our notes on translations, transformations. The transformations.